let's get started on this presentation. Today, I'm going to introduce everybody to DQMH, which is the world's most popular third-party framework for LabVIEW. Before I get started, I would suggest going to this URL and downloading the slides right now, because there are a lot of links in the slides, and y'all may want to check out a couple of the things as I'm talking about them. And the easiest way to do that would be to just download the slides. So I've got the slides and the demos there at DNAT DQMH intro, and this recording will be posted there eventually as well. So hopefully everybody got a chance to type in that URL or copy it down, and I'm going to go ahead and get started. So this is a presentation about a LabVIEW framework, and as such, I'm going to be using a lot of terminology while going through the introduction to DQMH. And so I've got a glossary here. This is another reason to download the slides, is because I'm going to be using a lot of terms throughout the course of the presentation. And if after I cover it and I use the term later and you've already forgotten what it means, if you've got the slides, you can go back real quick and take a look at the glossary. By the way, I have the parentheses as defined by me, because some of the stuff I'm about to talk about in this glossary, people would argue with me about what my definition of the term is, and that's okay. I don't really like to argue about semantics. So if you have a different opinion than I do about what some of this terminology means, that's okay. Just know that I'm going to be using the terms in these particular ways. So first of all, when I refer to the word process, I'm just referring to code that is running continuously. And with LabVIEW, that's almost always just going to be a VI that's got a while loop in it, or maybe more than one while loop in it. So when I say the term process, I'm referring to continuously running code. Also, I'm going to use the term reentrancy some. If you're not familiar with this term with LabVIEW, this is basically the ability to have a VI, multiple instances of a VI, the same VI, run at the same time. And it's just a configuration setting on VIs to turn on reentrancy. I'm going to use the term API a lot, and the term has a very specific definition, but for me, I'm just referring to groups of functions that are related. So the top picture there, that's the file API. You can open, read, write, close file. The bottom picture, that's the TCP API. You can open a connection, TCP read, TCP write, close connection. So when I say API, I'm just referring to functions that are related to one another and grouped in a logical manner. And then another term I'm going to use is business logic. So whenever you hear somebody use the term business logic, they are referring to the part of an application which is the code specific to that application. As an example, later on, I'm going to be talking about the ATM example for the CLD. If you have to write code that manages the user accounts, like their logins, what their balances are, whatever code you write for that, like if somebody makes a withdrawal and it reduces their balance, that math, all of that code related to that application, we would call the business logic. So if you're working with a framework like Active Framework or DQMH that I'll be talking about today, the parts of the framework that sort of facilitate or scaffold the framework, that's not the business logic. The business logic is specific parts of the code that relate to the application that you're working on. All right, more glossary. The term synchronous. I heard when I first entered the LabVIEW world and people use this term, I came from a mechanical engineering background. I didn't know what they meant. A synchronous process is one in which things happen in a serialized order. So in the picture here, we know that process B, it cannot happen until process A has finished. And once it's done, that's only when process C can start. So things have to happen in a certain order and things have to wait for other things to be done. If you're talking about an asynchronous process, that's the opposite. That is a situation where all of the processes are independent. So in this picture, process A, process B, process C, there's no data dependency between those in the LabVIEW world. So since they can run independently, we would refer to those as asynchronous processes. And then I'm also going to be talking about queues. If you're not familiar with the queue API in LabVIEW, it is a way to pass data within a process or between processes. As we can see in the screenshot here, we're using one queue to send data from the top loop or the top process to the bottom loop. And then events, it's another API that can also accomplish the same thing. In this case, we see that the bottom loop is generating an event that the top loop can then consume. And again, both of those loops, there's no data dependency between them. They're both running asynchronously. All right, I'm going to continue going with my glossary. Sorry I have to do so much background. It's pretty important for a topic like a LabVIEW framework. So this slide is the one where I kind of made up my own definitions for these terms, and people like Norm or other people probably disagree with my definitions, and that's okay. I think a design pattern is a theoretical mechanism in the LabVIEW world that is either going to execute synchronous or asynchronous code. I think a producer-consumer, for example, is a design pattern. It is a theoretical construct in LabVIEW that involves multiple loops and a queue to communicate between asynchronous processes. If we then take that to the next level, we've got an architecture, which is a real-world implementation that utilizes one or more design patterns. So, and usually with an architecture, it's templatized in such a way that there are places in the code that say, put your business logic here. And I have a few examples of architectures as well. And then we move on to the next level, which is a framework. And a framework is just an architecture, but it is a consumer-grade architecture. It is one that anybody can consume and use because it has extensive documentation and extensive tooling to improve your experience using that framework as a developer. And in my opinion, there are three main frameworks that provide all of those things, and those are DQMH, Active Framework, and JKI, State Machine Objects. Again, people will disagree with these definitions. That's fine. These are the definitions I will be using for this presentation. Now, you see up there, we have the term queued message handler as a design pattern. Now, given that queued message handler is a QMH and DQMH has those three letters in it, you might suspect that DQMH makes heavy use of the queued message handler design pattern, and you would be right. So I need to give a brief discussion and background of the queued message handler, specifically the NI queued message handler. This is a project template that was added to LabVIEW 10 years ago. If you go into LabVIEW and do create project, you will see queued message handler right there in the list. And when you pick it, you will get code that looks like this. And if you have prepared for the CLD in any way, you are probably pretty familiar with this pattern because this pattern is used in a lot of our CLD instruction. Like whatever prompt you get for the CLD, you might be able to solve it with a QMH. So let's make everybody really familiar with this pattern. Now, the QMH, as you can see, we've got two big old loops sitting there in the code. The event handling loop and the message handling loop. I will refer to those as the EHL and the MHL for the rest of this presentation. The event handling loop is typically going to enqueue things, and the message handling loop is typically going to dequeue things and then act on whatever that was inside of the queue. So we've got the queued message handler project template that's been around for 10 years. It's been around longer than that, but it's been codified as the NI QMH for 10 years. Now, for the past 10 years, LabVIEW has also shipped with something called the Continuous Measurement and Logging Sample Project. This is a project for a real-world application of data acquisition and data logging that is built on the NI QMH. And you can see the top half of that diagram is very familiar because it's got an event handling loop and a message handling loop, just like the NI QMH has. But it also adds on a couple of additional message handling loops, one for doing acquisition and one for doing logging. Now, the QMH, we know that the Q in QMH stands for the LabVIEW queue, and queues are used to pass data in between these asynchronous processes. And so we can see that queue references are being passed all around in this code. The UI message loop has queues for the acquisition loop and the logging loop. The acquisition loop has the queue for the UI and for the logging loop. There's queue references being passed around all over the place in this sample project. So we've had this pattern in LabVIEW for 10 years, right? Well, there are a lot, despite the fact that, you know, it's right there at the, you know, when you type in QMH in the create project dialog, it's right there in the list. There's a lot of problems with queued message handlers. I could probably get Norm to nod along in agreement with that statement. Here are several of the problems with the NIQMH. First of all, it's not exactly straightforward how to communicate between those different processes. We've got the main QMH, we've got the acquisition message handler, we've got the logging message handler. How exactly do we communicate between those? Well, in the code I just showed, we were passing queue references into sub-VI connector panes. Well, what if we need to throw on another asynchronous process? What if instead of measurement and logging to a file, we've also got some sort of data display UI that we want to have? What if we also want to log to a database? These are all additional message handlers we might need to add. So are we going to start adding queue references to the connector panes of these VIs for all these additional things we need to add? That's not scalable. Another problem related to that is reusability. Once I take a connector pane of a VI that's a message handling loop, and I take some other VI's queue and put it on the connector pane of that VI, I have now severely limited the usability of that message handler. For example, if I want to write a new application and I want to use the acquisition message handler from this code that I just showed, but my new code isn't going to have a logging queue. Well, this acquisition VI I have, has a logging queue reference on its connector pane, which it doesn't make sense for this new app. So now I'm going to have to hack away and get this code over here in a state where I can use it with my new app. And now I've got two copies of the code that are a little different from one to the other. Reusability is very difficult with the NIQMH for those reasons. It's also hard to support reentrancy with the NIQMH. If you were to open the continuous measurement and logging project and just take the top level VI and make it reentrant and try to call it multiple times, things won't work. There is some state management issues. There's also now going to be a single acquisition message handler being shared between multiple reentrant instances of the top level app. That's not going to work. The NIQMH does not easily support reentrancy. And finally, let's say you need to make changes to add a new message handler to the NIQMH. Everything has to be done manually. The creation of the queues, the creation of wrapper VIs for the queues, destroying the queues, adding new messages that could be handled to the message handler by typing in the string name on the frame. These are all things that can be tedious and error prone whenever you are having to do them manually. So over the course of the past 10 years, these are among multiple other reasons why the NIQMH has been found lacking in terms of its ability to support large asynchronous LabVIEW application development. So with all of that background in place, hopefully I've sort of set the stage for why we needed DQMH. So a little bit of history. DQMH has been around for 7 years now. It first released in 2015 and was developed by Delacorp, which is an NI Alliance partner. If you've ever wondered what the D in DQMH stands for, it stands for Delacorp. And if you've ever heard the name Fabiola de la Cueva, she is a pillar of the LabVIEW community, and she was the chief architect of DQMH. Only a year after it came out, it won the award at NI Week for the LabVIEW Tools Network Product of the Year, which is pretty cool. And then in 2018, a group of people were identified by Delacorp as being trusted advisors for DQMH. So there's now this program of probably about a dozen, maybe, alliance partners and consultants who are basically well-versed enough with DQMH they can be trusted to advise on its use. And then, believe it or not, there's a podcast about DQMH, and it came out in 2020. And most of the people interviewed on that podcast are trusted advisors that have a long history and knowledge of DQMH. And then in 2021, ownership of DQMH transferred over to an organization called the DQMH Consortium. So now it is sort of managed, instead of by Delacorp, it's managed by this organization, and their sole purpose is the improvement and advocacy of DQMH. And present day, DQMH 6.1 came out a couple weeks ago, or a couple months ago, I guess. It's the latest version as of this presentation, as of this recording, and the one that I'll be demoing and showing in my presentation today. All right, so let me give some basics about DQMH. It's free to download and use. It's on VIPM. It's in the VIPM community. Maybe you could install it right now while we're talking about it. And its purpose is to facilitate large application development in LabVIEW, just like any other framework, like Actor Framework. That's its purpose as well. It's by many measures the most popular third-party framework for LabVIEW in the entire world. You know how NI provides certification badges for various aspects of LabVIEW programming? NI actually provides a DQMH certification badge. That's how popular it is. So whenever we start looking into some code, we are going to see that within a DQMH module, and I'll talk about modules in a minute, the communication scheme is queues, just like the NIQMH. But when you've got a module that needs to communicate with the outside world, there's a different communication scheme, and that's user events. And possibly one of the biggest draws of DQMH is that at its fundamentals, this framework has been designed to be accessible to CLAD and CLD level LabVIEW programmers. The framework itself uses LabVIEW classes, but very minimally. And LabVIEW classes can sometimes be a sticking point for some LabVIEW programmers in terms of their ability to understand and work with the framework. That's the reality, even if some developers don't like that fact, it is a fact. And the fact that DQMH makes very minimal use of LabVIEW classes is a draw for some LabVIEW programmers because it is has a much lower barrier to entry. All right, so just like I needed to give some basic framework level glossary terms before, I need to give some DQMH glossary as well. First of all, we've got the term DQMH module. A DQMH module is an LVlib. It is a library in LabVIEW, and it basically wraps what we would refer to as a single asynchronous process with a well-defined public API to interface with that process. And a DQMH module can be singleton or clonable, and those terms are just other words for non-reentrant or reentrant. So if you have a module and you only ever intend for one instance of that process to be running at a time, it would be a singleton. If you intend for multiple instances of that module to be running at a given time, you would have a clonable module in that case. All right, a request. So a request is a way for the outside world to ask a module to do something. In the screenshot there, we see a request called start timer. So that is a way, and I'm going to be writing a timer module later in this presentation as a demo, but that start timer VI is a request for the timer module to say, hey, go ahead and start the timer. Also, you can optionally have that VI sit and wait and then return some information to you that the module wants to give. That's called a request and wait for reply. So request is one kind of event, and broadcast is the other kind of event. A broadcast is also a user event, but whereas a request is a way to tell a module to do something or to ask a module to do something, a broadcast is a way for the module to tell the world something. And there could be 0 people listening, there could be 10 people listening. The module doesn't care. It's just saying, hey, world, here's some information if you're interested in this. And that's a broadcast. So if you come away from this presentation knowing these 3 terms, you're already on a pretty good start with DQMH because these are the basic fundamentals of DQMH. A module, which is a library, requests, ask the module to do something, broadcast, module is telling the world something. There you go. That's the basic glossary for DQMH. Within a DQMH VI, DQMH module, there's going to be a main VI, which is the queue message handler VI for your application. That's where all your business logic is going to go, inside the main VI. There is also a tester, which lets you test your DQMH module to make sure it's working correctly. This is one of the most fundamentally useful parts of DQMH, is the fact that it provides an API tester. And then another fundamentally useful part about DQMH is the scripting tools. This is what makes DQMH framework a framework. There are tools built into the framework that allow you to create new modules, create new requests, create new broadcasts. They put all the scaffolding in place. Whenever I do my demo later, watch how many times I have to write code that deals with user events. I'll give you a spoiler, it's 0. I don't have to touch events the entire time I'm working because the scripting tools handle all of them for me. All right, so I'm going to do some live coding. It's kind of like, some people like to watch figure skating, hoping that people will fall down. You guys are probably hoping I'm going to, screw something up, but hopefully I won't. Hopefully I'll give a good demo of creating a simple DQMH module. And this module is going to be a timer module. If I've ever worked with you on preparing for the CLD, you've heard me say over and over and over again how important it is to know how to write a timer in LabVIEW. It's always fundamental to solving a CLD, and it's useful skills for writing real-world LabVIEW apps as well. So the timer module I'm going to write, it's going to be pretty simple. It's going to have a start, a stop, and a notification when the timer elapses. It's not going to have fancy stuff like a pause. I don't have enough time to do that in the presentation. So let me go ahead and switch over to LabVIEW and get started on that. And when I do, does anybody have any starter questions for me based on all the background information I gave so far? All right, hopefully you guys can see my LabVIEW project window. I set my screen resolution higher so things are easier to see. I got that tip from Norm.
Hey, Darren.
Oh, yeah, Ben, what's up?
Is there like a module manager that's managing all the modules that are spun up at runtime? Or is everything independently managed?
The question is there some sort of module manager? No, there's nothing built into the framework that does that. I have seen applications where someone will write a DQMH module that has manager-like functionality. The simplest example I can think of is I've worked with customers who have, they are communicating with a lot of serial devices, and they have written a serial communication DQMH module that is a clonable module, so multiple instances of it are running simultaneously, but then they'll have a serial manager module that is the one that sort of provides you with, here's a UI of your connected devices, you can manage those devices. But that's a module that they wrote themselves to do that management.
Okay.
All right, so what I'm going to do, I'm going to create a DQMH module with the scripting tools. So the first thing I'm going to do is I'm going to call it timer. I'm going to type in a description. I'm going to give my library a icon overlay so that my VIs are easily identifiable. And that all looks good. So I'm going to click OK. So this is going to create a new module for me. Now, remember I said earlier in the presentation that a module is an LVLib. And then along with that LVLib, we get a tester VI. And that tester VI is going to allow us to test the functionality of the module that we're writing. So it takes a few seconds, but here we are. We now have our timer module. So the first thing I need to do is I need to add requests and broadcasts. Now, remember from my slides, this is a really simple module. It's going to have a start, a stop, and then it's going to tell the world once the timer elapsed. So the first thing I'm going to do is I'm going to create an event to tell the timer to start. So we're going to call this is a request. Remember, we are telling the module we want it to do something. So here's my documentation. And we also need to tell it any parameters that are needed. Well, I need to tell it how long the timer should go for whenever I'm, start it, right? So we have a parameter called duration that we're going to use for that. Now, when I create this event, there are things that happen to my module main VI, which is where my business logic is. And there are things that happen to my tester. We can see here that it created code in my tester for me to test this new request. So I'm going to update the front panel of my tester VI. So again, this is the front panel of my tester, not of my module. It is a way for me to test my module. Now I need to add another request, which is to stop the timer. So we're going to say stop timer. And that's going to create a new request. And again, that's going to create more code in our tester for us to test and make sure that the stop timer functionality is working correctly. Then finally, I need one more event for this simple module that I'm creating, and that is a broadcast that tells the world that our timer has elapsed. So we're going to create a broadcast, which is going to tell the world the time has elapsed. And again, this is going to add code to my tester VI for me that allows me to test this broadcast and make sure it's working properly. Okay, so believe it or not, my tester is done now. I am ready to test my module. And notice also that I was encouraged by the scripting tools to keep my tester up to date as I created those requests in that broadcast. The scripting tools brought up the diagram for me with bookmarks in the code telling me, hey, you need to make changes here so you can test this new thing. So now my tester's done. Now I just need to implement my business logic. I need to write the actual code that starts the timer, stops the timer, and tells the world that it elapsed. And that is going to take place in the DQMH main VI. So if you've worked in queued message handlers before, this is probably a pretty familiar pattern. You've got an event handling loop up here. You've got a message handling loop down here. You've got your data that is local to your application here. So let me go ahead and make a few changes. I need to know, so this is all data that is local to my timer. I need to know that the timer is enabled. I need to know what the duration is, and I need to have a timestamp that is when the time started. So that should be good for the actual local data that my app needs. Now, when I initialize, I probably want to make sure that there's known values that are stored for those. And again, if you've ever worked with QMHs, if you've ever worked with solving a CLD, this should all be pretty familiar stuff to you. Make sure your data is initialized. And then let's see. Okay, so I know for a fact that the stop timer code is going to be easy because when the stop timer request comes in, I just need to make sure that we are no longer doing any timing. That's good. And then now I need to go look at the start timer code. So this is code that's going to run whenever that start timer request comes in. And I know that when the start timer request comes in, I want to enable the timer. I want to specify the duration that got passed in by the request. And I want to store a timestamp for the start time. And since this is a QMH type design, we should be familiar with enqueuing messages into the message handling queue. Now, there are more elegant ways to solve this than what I'm about to do. I'm going to have this loop message itself for the purposes of my demo. For other code, I would probably write a separate loop, but I'm not going to get into that topic now. I just, at this point, just need to write my check time code. All right, so we are almost done with this because I just need to write my check time logic. So if the timer is enabled, then I need to go check some logic on, by the way, sorry for my messy code here. I need to go see if the time that between the starting timestamp and the current timestamp is bigger than the duration that was specified. And if it is, then we are done and the timer has finished. So this VI right here was created for me by the scripting tools to send a broadcast that timer has elapsed. And when we do that, we want to make sure to turn the timer off. But if the time difference between the start time and the current time is not bigger than the duration, then we want to call this same code again. But we also want to make sure to put in a delay because otherwise this code is going to run as fast as possible, which is not necessary for a low resolution timer like this. All right, I just finished implementing my business logic for my DQMH module. I've already got a tester. So why don't I go ahead and try out this code and see if it works? Oh, wait, you know what? One more thing for debugging purposes, this particular DQMH module doesn't have a front panel that we need in any way. Its front panel is useless. It's not something that's viewed by the end user, since this is just a timer module that's broadcasting time. However, it might be useful to have a time indicator on the front panel to tell us how much time has elapsed. So I'm going to put that there. Okay, now let's run our module. I'm going to start the module. I'm going to set a duration of 2 seconds and click Start Timer. After 2 seconds, I should see a broadcast telling me that the time has elapsed, but I'm not seeing that. Something is wrong with my timer. So I need to debug this application at this point because I screwed something up and I just wrote that code for y'all. So the first thing I'll do is I will use this button to show the module panel. Maybe I'll see if the time is elapsing, but something about my logic wasn't working right. So if I start the timer, I see that time is not incrementing. I should see that time right there should be increasing. It should when I click Start Timer, but it's not. So there's something else is wrong with the code that I just wrote. So I'm going to use this debugging tool in DQMH to show the block diagram of the code that's running while it's running, so that I can use debugging tools like probes. So let me check if my logic is correct on that checking of the duration against the timestamp difference. So I'm going to click Start Timer again. And that code isn't even running. So if I go back to my code and look, well, let's look at the Start Timer code. It looks like I am setting enabled true here. There's the problem. Look, this should be the true case, not the false case. I'm running this code when enabled is false. It should be true. So thanks to the DQMH debugging tools, I can go into this code and change this case to true and run again. And we'll show the panel again just to debug. We'll set a timer of 2 seconds again. Now we see our time is incrementing, and we see that we got the broadcast saying that the timer has elapsed. So thankfully, I fixed my code with those debugging tools that were built in. If we start the timer again and stop the timer, we'll see we don't get the broadcast. If we start the timer and start it again and start it again, it continues to restart okay. It looks like my timer module is working. So that was cool, right? I wrote a module pretty quickly, but how do I actually use this module that I just wrote? Well, let me show you. I actually have my CLD code that I wrote with DQMH right here. So here's the CLD. If you've ever looked at the ATM sample exam, that's this code. And I'm going to run it, and I'm going to insert a card, and I'm going to type in my user ID. And if you've ever worked on the CLD sample exam, this should all be very familiar to you. I can do a balance inquiry. I can take out some cash, balance inquiry, it's updated. But one of the features of ATM that's described in the CLD time and the CLD prompt is that if there are 10 seconds of inactivity on the ATM front panel, your session has to be terminated. And as you can see, that's what happened in the UI just now. I didn't use it for 10 seconds. It shut down, ejected my card and shut down the app, right? Well, this is a good app where I can use a timer, right? So if we look at the code, there's my start timer VI, the VI that starts the module. There's the VI that actually starts the timer. And if we look at the code, we'll see that in various places where you do user interface actions, I go ahead and start the timer. But then notice this code is registered for the timer elapsed broadcast. So if the timer ever elapses, that means 10 seconds of inactivity have happened, and we can terminate the application. So this is a case where we had this module that we wrote, we tested it, made sure it worked, found a bug thanks to the tester, fixed the bug. Now, how would things have worked if I didn't have that tester? I would have put all the timer code into this ATM code. I would have run it. Things wouldn't have worked. And what, now I have to run the entire ATM application to try and figure out why my timer's not working? That is not good software engineering practice. If you have modular code and testable code like you get with DQMH, like it encourages you to have, then it's much easier to find those problems before they get integrated into the main application. One other point I want to show is if we go back to the timer project and go look at the main VI. So here's the main VI. This is where I wrote all that code. And did y'all see that all the code I wrote was in here? This is where every single thing I dropped to implement the business logic of my application resides. I didn't have to do anything over here where there's business logic, or I'm sorry, where there's framework code having to do with DQMH. I didn't have to do anything over here, which is where things are being shut down. I didn't have to do anything up here in the event structure, which is where things like the request events are coming in, like stop timer, start timer. Now, if this were a user interface related application, then sure, I'm going to write some event code to handle clicking buttons and stuff on the front panel. But this is a DQMH module that doesn't have a front panel that I use. And so all of my work was focused down in here. If you were to start digging into some of the VIs of DQMH, like the start timer VI, this is the VI that sends the start timer request. There's a user event there, there's error handling there. I didn't write this code. The DQMH scripting tools wrote this code for me. I didn't have to do anything with events because the framework handled the entire scaffolding of my application so that I could focus on my business logic. And then one more thing that I'm going to show about DQMH in the code, and then we will get back to the slides, which is this is a pretend application that calls some DQMH modules. Does anybody recognize this pattern with an enum over here and a case structure here and the fact that it says state machine up here? This is a state machine. This is a simple state machine, but it is using the public API of DQMH modules to do things like do something and another do something. And even though singleton and clonable are the two, whoops, wrong project. Switch back over to the project. We've got two modules called singleton and clonable. We're calling their public APIs within the code of the main application. The main application is not a DQMH module. It's just a simple state machine. But we can use these DQMH modules by calling their public APIs within there. So you're not restricted to writing everything with DQMH if you don't need to. It's perfectly acceptable to have your DQMH modules with their public APIs and call those wherever you want. That's inside of a state machine. That's inside of another DQMH module. That's inside of Actor Framework. Perfectly fine. The outside world doesn't care. It's just calling public API VIs of DQMH modules. All right. What do y'all think about that demo? Any questions or comments about how to implement DQMH and use a DQMH module? All right, so let's talk a little bit about what we learned. There are a few roles that a LabVIEW programmer is going to have when he's interacting with DQMH. Maybe you are a DQMH module developer, like I just was when I wrote the timer module. In that case, it is imperative to keep your tester up to date. That is how you're going to make sure that your module works, that you don't break things, that as you add functionality, it's immediately testable. There's a document online, DQMH best practices. There's a lot more to DQMH than what I showed in that demo. There's concepts called helper loops. There's concepts called request and wait for reply VIs. Those are all more advanced topics related to DQMH that have best practices associated with them. You should never, ever have to edit a user event-based VI in DQMH. The scripting tools should handle all of that for you. If you find yourself going in and manually dropping a create user event function somewhere, you're doing something wrong. You're not using the scripting tools the way you should be. Make sure you document everything. Did y'all notice that in my demo, even though it was a demo, I was typing descriptions for my module and for my requests and for my events? Because it's a habit and it's because it makes things easier for yourself and others as they encounter your code. There is a tool called Antidoc, which is amazing at generating project documentation. If you type in those descriptions when you create the module and when you create the events like I did, you will never have to type another sentence of documentation for a DQMH-based project again. Also, it generates really awesome diagrams like that one on the right. So, and this might go to Ben's question from earlier about managing your code. This Antidoc created that picture that you see for my DQMH-based ATM. Looking at that picture, I can tell you, timer broadcasts to ATM, account manager broadcasts to ATM, ATM sends request and wait for reply messages to account manager. I can tell you all that just by looking at this picture. And the most important thing, there's no dependency between timer and account manager, which makes them both very reusable modules. All of these things are available when you use a tool like Antidoc to document your DQMH code. Another thing, when I did that demo earlier, when I created the timer module from scratch, I created it from my own module template. The base module templates that come with DQMH have a whole bunch of extra crap in them that I didn't need for my demo. So I created my own module template that has all of that extra crap stripped out, and it's just a bare bones DQMH module. That's what I started with for this demo. That's what I can also start with other modules for and other projects that I work on because I've got a module template. Now, maybe you're not a DQMH module developer. Maybe you're a DQMH module user. Maybe you really liked that timer module that you saw me write and you want a copy of it. You don't want to add anything to it. You just want to use that module in your own application. In that case, hopefully your module has a palette that you're using, because just like any other API, just like the file API or the TCP API that I talked about before, any sort of API should have a palette or some sort of organization. And hopefully, if you got a module from DIPM, it's going to have that palette built in. But if not, there's a couple of places you need to look to find out how to use the DQMH module. If you need to use the requests, they're going to be in the public API folder of the module library. If you need to use broadcast, you're just going to see the list of them in an event structure where you're registered for DQMH events from. Now, there are several default requests and broadcasts built into DQMH. Y'all saw me use a couple of them when I was debugging that problem in my module, when I had to show the panel to see that debugging numeric on the front panel, when I had to show the diagram to go set probes while it was running. These are requests and broadcasts that are built into DQMH that you don't have to create. They're always there themselves. They're always there for any module you work with. And then finally, if you're a module user, why not open the tester VI that the developer wrote and maintained to see examples of how to use that module's public API? This has happened to me with lots of projects I've worked on where I write a module, I create a palette for it in DIPM, somebody installs it, and then the first thing they do to figure out how to use my module and its public API, they look at the tester and see how I'm testing all of those public API VIs. Let's talk about some benefits of using DQMH. I'm going to sound like a broken record here, but the scripting tools automate changes to the framework that you don't have to worry about. You create a new module, a new request, a new broadcast. All of those things are handled for you with the scripting tools. You don't need to worry about anything in the framework to support those features that you're adding. Another cool thing about DQMH that a lot of people don't realize, there's a feature of DQMH called module validation. So DQMH is software. Software has bugs. Every framework, every architecture has bugs. Those bugs get fixed. Actor Framework came out in 2012. With almost every release of LabVIEW, there was some fix that went into some bug that was in Actor Framework. That's fine, it's still a great framework. Same thing with DQMH. DQMH came out in 2015. It's been 7 years. There have been several releases. There have been bugs in the framework that have been fixed. But check this out. There's a scripting tool called validation where you point the validator at your module and say, hey, are there any bugs in my module that have been fixed in the latest DQMH release, it will identify what parts of your code have those old bugs, and it will actually fix those for you. It's an amazing tool in DQMH that I haven't seen in any other framework. And then another benefit of the scripting tools, y'all saw that when I used it on my timer module, as soon as I created the start timer request, what did I see? I saw the tester. I saw bookmarks in the code saying, hey, support this new request you just created. The scripting tools encourage you to maintain your code by keeping your tester up to date. Another benefit of DQMH. If you have ever worked with a queued message handler, the part of the demo where I implemented my business logic should have been very familiar to you. CLAD and CLD level LabVIEW programmers are familiar with the QMH pattern, and because of that, DQMH has a very low barrier to entry for implementing business logic. In fact, I would go so far as to say that if you had never used DQMH before, and during my demo, I created the 2 requests and the 1 broadcast for my timer. And after I did that, I handed my code to you and I said, I know you've never used DQMH, but can you implement a timer by adding code to this message handling loop here? Pretty sure you would have been able to do that because of how familiar the QMH pattern is and how accessible it is to most CLAD and CLD level LabVIEW programmers. Another benefit of DQMH is the fact that it just handles fundamental aspects of LabVIEW programming for asynchronous processes with 0 extra effort on your part. When I did my demo, I started my module, I showed its panel, I showed its diagram, I stopped my module. I wrote 0 code to facilitate all of that because DQMH handled all of that for me. Starts when you tell it to start, stops when you tell it to stop. Basic management of things like errors and panels. Now, there's more sophisticated things you can do with error management. DQMH has a basic level of it. And then there's the built-in debugging tools as well. There is an extremely active developer community on ni.com for DQMH users. And people ask questions there all the time, and those questions are usually answered by other DQMH users or DQMH trusted advisors, like I mentioned before. And hopefully you guys have seen the LabVIEW idea exchange where you can submit ideas, feature requests for LabVIEW. DQMH has the same thing. There is a feature request page on ni.com where you can submit feature requests for DQMH. And I got to say, the DQMH consortium is very responsive to those feature requests. Every release of DQMH for the past 2 years has included several features that were originally posted on the feature request page on ni.com. And then there's way more benefits of DQMH. There's a company called Hample Software Engineering. They have a web page where they list the benefits they've identified. They also have a funny quote on their web page where they say, DQMH is our hammer. I'm paraphrasing here. DQMH is our hammer. We make sure every one of our projects is a nail. I thought that was kind of funny, but they're so skilled with the framework and they have so much faith in it that they try to use it for pretty much all of their LabVIEW projects that they work on. All right, so this presentation was just an introduction, right? This was not like going into the details of how to write DQMH code. I just wanted to introduce the framework to everybody, show a simple demo, give some glossary, give some resources. Hopefully you download the slides and click on the links that are in them. But what's your next step at this point? If you want to learn DQMH, how do you learn it? Well, there are a bunch of ways to learn DQMH. The first is its documentation. If you click the link that's in the slide, you will be taken to the DQMH documentation where they have a page that basically provides, here are several ways to learn DQMH. If you like to learn from instructional videos, go here. If you like to learn from browsing example code, go here. If you like to learn from being taught by an instructor, go here. That's all available on that first link there. Now, to go into a little bit more detail on some of the possible ways to learn DQMH, there is a guy in the UK named Tom McQuillan. He is a LabVIEW expert he's also a very, very good presenter. And he has video series teaching various aspects of LabVIEW programming. He has a Tom's LabVIEW Adventure series on DQMH. He also has one on Actor Framework. If you want to learn Actor Framework following Tom McQuillan's videos, he's got a series for that. He makes really good videos. And so that's a great place to start if you like to learn by watching an instructional video. The DQMH Consortium also has really good videos, most of them by Fabiola, who originally wrote DQMH. She has a ton of videos going into detail about how to learn various aspects of DQMH. There is an official training course. If you have a customer who wants to go to the next level and get taught by likely a DQMH trusted advisor, they have an official training course for that. The podcast is a great way to learn how the DQMH trusted advisors are use DQMH. There's a shipping example for DQMH. It simulates a thermal chamber where you've got UUTs that are going under thermal testing. And it is a very well documented shipping example. And I like this example because it really illustrates how once you had DQMH modules, how you use them by calling their public APIs.